Okay, share screen.
Good evening, sir.
Yeah, good evening.
Sir, are we going to do exercise problem, sir?
Yeah. Okay. Examples. Did you try something? Anything which you had trouble? Exercise or examples? If you have any doubts, we can answer that first before we get started with the additional exercise problems. I mean, other exercise problems. Anybody having any doubts? No doubts at all. Nobody tried anything.
Good evening, sir.
Yeah. Good evening. Okay. Looks like you folks are not having any doubts, which means either you must have tried everything and got it right, or you have not tried it at all. Let's see.
So, what was done in the last two classes?
What's that?
In the last two classes, what was done?
Finish the chapter. I asked you to go through the video. I will upload it in the YouTube. It's your duty to watch the video and study it.
Yes, sir.
Check with Satya madam also. You can get some help if you want. Okay, so let's see. This chapter I have classified it as easy, medium, and difficult. So take it down. 4.6 is difficult. I will note down the difficult and medium. All the other things will be easy. So difficult problems are 4.6. Mm, 4.7. Medium 4.10, 12, 13, 14, 15, 19, 20, 21, 22, 23, 24. Thirty, 31, 32. Okay. So note it down properly. These are all difficult problems. These are all medium difficulty. All the other things are easy. So whenever I say easy, I expect you to do it yourself. If you have doubts, we can discuss, but mostly I will not be doing it in the class. But if you have doubts, we can discuss it. Okay, let's get started quickly. So this is a vector-based problem. So Maybe we'll come back to this when does the equality sign. So this vector problem, we'll come back to it. Let's take some easy ones first. Four point 10. Let's take a look at 4.10, the medium one. On an open ground, a motorist follows a track that turns to his left by an angle 60 degree. So that means after every 500 meters. So he's going 500 meters and then he's turning 60 degree like this. So again 500 meters and then he's turning 60 degree. Again he's going, so instead of going straight like this, he's turning 60 degree here. So this is a 60 degree. Instead of going straight like this, he's turning 60 degree here. That's the meaning of this. Starting from a given turn, specify the displacement of the motorist at the third, sixth, and eighth turn. So it means if you carefully observe this problem, what will happen is you will see that this will become a hexagon, a regular. Yeah, it's a regular hexagon. Okay. Why? Because if you take the center point over here, right? This entire angle is 360 degree. You know this. So suppose if I divide this into 6 triangles. So this has to be 60 degree. So this is 60. This and this, it's a regular hexagon, which means this will be 60, this will be 60, and this will be 60. And that's why it will be 180 degree here, this one entire thing. So since they say 60 degree here, right, you'll be able to guess that it's a regular hexagon. So once you guess this, I think this problem is very easy. Starting from a given turn, specify the displacement of the motorist at the third and sixth. So that means, so let's say you're starting from here. So this is your starting point. So this is your first turn, second turn, third, fourth, fifth, sixth. So they're asking to find the displacement of the motorist at the third and sixth and eighth turn. So first, second, third. So this is the displacement they are asking you to find. So if I really draw this properly, right, you will see that this will go something like this. So this is a path taken, this is a displacement, right? So
Sir, we can name the vertexes, that 6 vertexes as A to F, sir.
A to
F. For example, that first one is A and then second one is B. So that if we need to find the displacement
yeah.
at the
So
6,
basically you have to find the displacement between this point and this point.
we can name that point as F and C, sir.
F and
When we
C,
write,
Y, F and C. Okay, you mean instead of numbers, you want to name it as A, B, C, D.
that is, sir.
Okay, doesn't matter. A, B, C, D, E, F, G. Can come back to the same point. So basically, you want to go from here to here, right? So this side is given. This angle is given 60 degree. So this is going to be equilateral triangle. So you can easily say that if this is 500 meters, right? This will also be 500 meters. This will also be 500 meters. Why? Because it's an equilateral triangle. So that means 500 plus 500, it will be 1000. So the distance between A and D will be 1000 meters. That will be your displacement. So that's the first or the third one. Okay, third term. Since they have called it as first, second, third, I named it as 1, 2, 3. If you want ABCD, you can name it as ABCD. Doesn't matter. Sixth turn means you are coming back to the same point, which means the displacement here will be 0. Because you started at one point and then you are coming back to the same point. So that means the displacement is 0 meters. Here the displacement is 1000 meters. The eighth turn means this is 6th, 7th and 8th. So he's going to keep going around again and again. So that means this will be your 8th turn. So that means this will be the displacement. Which means if I redraw this diagram, so 500 meters here, then 500 meters here. So that's an isosceles triangle. This is your 60 degree. This is also 500 meters. So I'm supposed to find the distance between A and C. This will be my displacement which is required here for the 8th term, because 6th, 7th and 8th term. This is 500 meters. If this is 60, you can easily say that this is 120 degree. You can use your cosine law because you know this side and the angle between them, which means if I use my cosine law, I'll be able to calculate this one. That means I can say c squared is equal to a squared plus b squared minus 2ab cos c, which is 120. So a squared plus b squared is going to be the same, so 500 squared plus 500 squared minus 2 times a into b, so 500 into 500.
There is a resultant vector, sir, here.
Sir, AC, yeah, it's just I'm simply using the cosine law. Right? You don't have to worry about the vectors here. This is one side, this is another side. This angle is known, which means you know that cosine law will give me this third side if I use A, B, C, and this side is the C. You following what I'm saying or not?
Yes, sir.
So cos C will be this angle, cos 120. So go back and study, you know, if you're not following this, you have to go back and study cosine law, which I already given. So if I want C, I have to take the square root here. So do the math and you'll get the answer. So this will be 500 square. Cos 120 will be cos 180 minus 60, right? 180 minus 60. So second quadrant is cos is negative. So negative, negative, it will become plus. So this will become cos 60. Cos 60 is 1 by 2, 1 by 2, 1 by 2, and 2 and 1 by 2 will cancel. Okay, if you want, I can write one more step here. So this is 500 square minus, this will also become 500 square, and then the 1 by, there is a 2 here, and then this cos will become 1 by 2. Why? Because cos 180 minus 60. 180 minus 60 means it is second quadrant. Second quadrant cos is negative, which means I'll be getting minus cos 60. Minus cos is 60. This will become minus of minus, it will become plus. So I can cancel this 2 and this 2. Cos 60 is 1 by 2. So this will become 3 times 500 square. 500 square will come out. So what is left is root 3 inside. So that will be the displacement. You can leave it like this, or you can do 1.732 into 500, whatever that is. Okay. So the idea is, it's very, very simple. The idea is you should get that since they are saying 60 degree or turning, you should get the idea that it is a regular hexagon. Anybody not following anything? So this is your third thing, eighth turn. Copied? Anybody still copying?
1 minute, sir. Can you move a little up, sir?
This one?
Yes, sir.
Okay. Four 4.12 we have discussed this many times. Okay, even in the previous chapter we have discussed this, but since this is vector thing they are asking you, we can quickly discuss this. I'm sure this is a very easy one for you. We've discussed this many times. Rain is falling vertically with a speed of 30 meters per second. So it means vertically velocity of the rain is equal to 30.
Sir,
Yeah.
your voice is breaking, sir.
Okay. Just a sec. Just give me a sec. Let me change my internet. Okay. Can you hear me?
Yes, sir.
Yes,
Okay.
sir.
Okay. So velocity of the rain is equal to 30 meters per second. A woman rides a bicycle with the speed of 10 meters per second in the north to south direction. So north to south. So let's assume that this side is north, this side is south. Okay. Generally, we in the page we'll assume something like this, but in this particular problem, I have to show the arrow. So north to south means I have to show something like this. So that is 10 meters per second. So this is velocity of the woman. What is the direction in which she should hold her umbrella? That means I told you the very first thing is you have to understand that this is type 1 or type 2.
Type 2, sir.
Type
Type
2.
2, sir.
Why? Because forces are acting on two different things, right? So that means
Yes.
it should be type 2. So that means velocity of the woman is like this, velocity of the rain is like this. So what this means is velocity of rain with respect to the woman. So it's something like this. So this is velocity of rain with respect to woman. It means velocity of rain with respect to woman. I told you final minus initial. So when the arrow comes here, this is final, this is initial with respect to woman. So that means, so we are doing vector subtraction, right? We are not doing vector addition. And this is 10, this is 30. So using this, you will be able to find the angle. So that means the woman should be holding the umbrella in this direction. So this is the angle which you need to find. So which is tan theta is equal to opposite by adjacent. 1 by 3. So theta is equal to tan inverse of 1 by 3. 1 by 3 0.3, which is less than tan 45 is 1. So 1 by 3 must be 1 by root 3. I don't know, something less than 30 degree. Okay, that's all. So take it down. Can I go to the next one?
Yes, sir.
This also we already discussed this, okay, but you will get many questions based on this river problem. Man can swim with a speed of 4 km per hour in still water. How long does he take to cross a river of 1 kilometer wide? So that means there is a river like this, which is 1 kilometer wide, and he can swim across the river at the speed of still water, means there is no other current. So in that case, he can swim like 4 kilometers per hour. So velocity of the man is equal to 4 kilometers per hour. How long does it take to cross 1 kilometer wide if the river flows steadily at 3 kilometers per hour? So that means the velocity of the river is equal to 3 kilometers per hour. He makes his strokes normal to the river current, which means he is going straight like this. How far down the river does he go and when he reaches the other bank? So how long does he take? So that means they're asking you to find the time taken to cross this. But you know that velocity of the, so this is type 1 or type 2?
Type 1, sir.
Type 1, yeah. So velocity of man. So both are acting on the same person. So it means I can say that the resultant is going to be somewhere here, type 1. So this is 3 kilometer per hour. This is 4 kilometer per hour, which means this has to be 5 kilometer per hour. The resultant magnitude will be this way, because the river is also pushing him this way. Using Pythagoras theorem, you can see whenever you see 3 4, right, you can say that the other side is 5. So Pythagoras triplets. Let's see, they given you the distance as 1 kilometer. So what I can do is, the displacement on this side is 1 kilometer. The speed on this side is, in this direction, is 4 kilometer per hour, which means I can find the time taken. So you know that velocity is equal to distance by time. So I'm talking about y direction. So velocity in the y direction is equal to distance in the y direction divided by time taken. So time taken is what is asked. So that means time taken is equal to distance in the y direction divided by velocity in the y direction. Distance in the y direction is 1 kilometer. Velocity in the y direction is 4 kilometer per hour. The kilometer cancels, per hour goes to the top, so it will be 1 by 4 hour, which is nothing but 15 minutes. So it takes 15 minutes for him to cross the river. So that's your first part of the question, A part of the question. Any questions? Very simple. I'm just considering only the y direction because distance and velocity is known for the y direction. Something like a projectile motion, you can consider x direction, y direction as individual movement. How far down the river does he go when he reaches the other bank? And he makes the strokes normal to the river. Okay, so they're asking you to find, we know that he's not going to reach this point, he's going to reach this point. So they're asking you this distance. So this distance is x-axis or y-axis?
Checks.
X. So do you know the velocity in the x direction? He's getting pushed by the river in the x direction by
Sir,
3
3
kilometers
kilometers per hour.
Yeah, that means this is distance in the x direction. This is the velocity in the x direction. Okay. So you know the time taken. So when he reaches here, it doesn't matter whether it's y direction or x direction, the time is same, right? If it takes 15 minutes for him to come from move this 1 kilometer in the y direction, he has actually moved both x direction and y direction in the same time. So that means it's same like your projectile motion. That means I will say the time taken is 1/4 hours. Anybody not following this? Just like a projectile motion, right? So I told you when the ball is falling down like this, right? If it takes 5 seconds for it to come here, I will say that this height in the y direction is also traveled in 5 seconds, and this distance in x direction is also traveled in the same 5 seconds. That's the meaning of this. Similarly, I'm saying that if I consider this as dy and dx, so this distance is covered in 15 minutes means it happened the y direction and x direction. So that means the distance is equal to velocity into time. Velocity is 3 km per hour. Time is 1/4 hour. So I can cancel the hour and hour. So I'll be getting 3/4 kilometers. So what this means is he will not be landing here. He will be landing 3/4 of a kilometer away from this point. Or you can see 0.75 kilometer. And due to the computer screen problems, I'm just writing here and there because of the space constraints. So take it down properly. This is your A part, this is your B part. Any questions, any doubts?
So can you show the yellow part of the curve one second? Yeah.
It's same like a projectile motion problem. Only thing you are splitting this into X and Y direction separately.
Complete.
Very interestingly, they didn't ask you to find the resultant here, but still, since when I'm drawing the vector, I just, took it as this is 3 and this is 4, so this is 5. 3 squared plus 4 squared square root. And if you really calculate so I'll show you something very interesting. This is 1 kilometer, this is 3/4 kilometers. So if you calculate this distance, and then if you divide by this time 1/4, right, you will actually get 5 km per hour. Okay, so if you want, you can double check that. So quickly do this. So what I'm trying to say here is just for double checking. I'm just saying we did the x direction, y direction separately. So this was 1 kilometer. This was found to be 3/4 kilometers. So if I want to find this
But instead of
distance,
doing, we can use Pythagoras theorem to find that 3/4 kilometers, right, sir? That is, that hypotenuse is 5 kilometers per hour.
yeah, you can do that. Yeah, that's what, either you could have found this distance and then you could have found this. Yeah, that's also possible. But this method is very, very easy. Okay, x direction, y direction. So that's why I like this method. But just for double checking what you're saying, that's what I'm trying to say here. So if you do the math here, right, we'll be getting the distance here as
Actually, 5 can't come, sir. It is actually kilometer per hour and it is not kilometers. So what is it is wrong, sir?
what's that?
So that is I meant to say that the method what I'm trying to do is wrong, sir. Actually, 5 cannot come.
No, what you said was You took the 5 directly, but what I'm saying is you know that it takes 15 minutes, right? Which means you could have found this distance. If you know this distance, you can calculate this distance easily. So after converting this to distance, you can calculate this.
Okay, sir.
So look at this. If I take this as 4 squared, it will be 16. So 16 plus 9 will be 25. 25 by 4 squared, so which is 5 by 4. So that many kilometers. Okay. So again, if you calculate the velocity here, we found it as 5 kilometer per hour. So that means time is equal to distance by velocity. Distance is 5 by 4 divided by 5 by 4 kilometers. Divided by velocity is, we found it as 5 kilometer per hour in this hypotenuse direction. This one. That means this is 5 kilometer per hour. 5 and 5 will cancel. So kilometer cancels. So hour goes to the top. So again, I'll be getting 1 by 4 hour. And that's what we got earlier. So I'm just trying to show, okay, this is just for double checking. So you should understand whether you do it in the x direction or y direction or in the hypotenuse direction. Everywhere you'll get the same result. Anyone following this? Anybody not following? Okay, quickly copy this. Can I change the screen? Anybody still copying?
1 minute, sir. Yes, sir.
Okay. 14 is also a very, very interesting problem. So let's try 14. Again, remember, I'm just getting you started. Okay. It's your responsibility to work out as many problems as possible. There is absolutely no limit. Okay. You have a lot of problems in internet. You have a lot of problems in your textbooks and, other guides. You can work out and practice. In a harbor, wind is blowing at the speed of 72 kilometers per hour, and the flag on the mast of a boat anchored in the harbor flutters along northeast direction. Northeast direction. Okay. If the boat starts moving at a speed of 51 kilometers per hour to the north, what is the direction of the flag on the mast of the boat? So the wind is blowing at 72 kilometers per hour, and the direction of the wind is, flag on the mast is along northeast direction. So that means northeast direction means somewhere here. Okay, because you know that this is north, and this is east, this is west. That means this is north, northeast should be here, exactly at 45 degree. And this is wind speed. If the boat starts moving at a speed of 51 kilometers per hour towards the north, so that means when the, to say this, let's say this is a flag on the boat. So if the boat is going this way, you can imagine that the flag will be, fluttering in the opposite direction. If the boat was going this way, then you can imagine that the flag will be fluttering this side. Okay, I hope everyone is able to understand this. Okay, because even if there is no wind, right, the flag will try to go in the opposite direction, because with the respect to the ground, right, it will be going in the opposite direction to the boat. So that means if I say the boat is going in the north direction, the flag is going to be experiencing a force in the opposite direction. It's something like when the car is going forward, we get pushed backwards. So similarly, when the boat is going forward, the flag will get pushed backwards. So it means the flag is going to experience a force southwards, because the boat is going it northwards. So this is going to be south direction. This will be 51 kilometers per hour. What is the direction of the flag on the mast of the boat? So that means due to the movement, it is going to experience something this way, and due to the wind, it is going to experience something this way, which means what will be the resultant? Like, is this going to be a type 1 or type 2?
So type 2.
Type 2. Why?
So because both force and winds,
Both force and wind are?
both going in the direction. Because of that, the flag's going backwards. And because of the wind, it's pushing the flag. So it's a type 1. Both are on the flag. So
Yeah, type 1. Okay, it's not type 2, because both the wind is also pushing the flag, and then the boat movement is also pushing the flag, which means both are acting on the same object, which means it should be type 1. Everyone okay with that? Anybody not following? So that means if I draw the parallelogram, right? So this is one vector, this is another vector, so this is my parallelogram. Again, remember, we are not drawing like a perfect, we are not drawing to scale. Okay, so if I draw it to scale, probably I'll get a better diagram. So that means your resultant is going to be somewhere like this. So that means you can find the resultant velocity, and then you can find the resultant direction. Okay. So what is the theta between this and this? This is 45, this is 90. So 90 plus 45 will be 135. So let me take this as my first vector, A vector. And let me take this as my B vector, because it's easier if I take it straight. So that means the angle between them is theta 135. And I'm supposed to find the alpha with respect to the first vector, that is my alpha. So we studied that this is your alpha. Okay. In your theory, we took it as A and here, B here, then the resultant was this way, and then we took this as my alpha. Here I'm saying let's take this as the first vector, which means this is my alpha. What is the direction of the flag on the mast? So they didn't ask you to find the velocity, right? They're simply asking you to find the direction. So that means I have to simply find the tan alpha. So anybody remember tan alpha formula? Tan alpha is equal to B sin theta divided by
A plus B cos theta.
A plus B cos theta. So B sin theta is this thing, and theta is 135 degrees. So that means you know theta and you know A and B. So that means you can simply substitute and get the answer. So B is 72. Sin theta is sin 35. Sorry, sin 135. Anybody not following this? Angle between A and B is 135. 45 degree plus 90 degree. Because this is 45 degree, they gave it in a tricky way, northeast direction. Northeast means north is here, east is here, which means northeast is exactly the center. Divided by A plus B. A is 51 plus 72 into cos 135. Let's all simplify this and you should be getting the answer. Sin 135 will be sin Anybody? Sine 135 can be written as sine 180 minus 45. Is that right? Which means it's second quadrant. Second quadrant sign is positive, all silver teacups. So this is positive. So sine 45. Sine 45 is 1 by root 2. Right? And then similarly cos 135, let's see what I will get. Cos 135 will be cos 180. As I said, whenever possible, I like to write it as in terms of 180 rather than 90 because
it is cos minus 45.
yeah, cos is negative, which means I will be getting a minus. Cos with 180 will become cos 45. Cos 45 is also 1 by root 2, but there is a minus here. So 72 1 by root 2 divided by 51 minus 72. Because of this minus, I will be getting a minus here by root 2. Simplify this and find the, remember this side is not theta, it's tan alpha.
So this will be 51 by 72. 51 by 72 root 2 minus 51.
Is this correct? Root 2 I can cross multiply here. Root 2 will cancel. So 51 root 2 minus 72. So do that and you'll get the answer. Okay. Alpha is the angle with this one. So I think I'm wondering if I'm making any mistakes here. Let's see. Okay, so that is correct. 51 root 2. So let's check what is 51 root 2. Root 2 is 1.4 something. So 1.4 into 51. 71.4. So what this means is this is very close to 71.4. So this and this will come very, very close to 0. Okay. So that means tan alpha. So anything by 0 will become infinity, which means alpha will be very close to 90 degree. So what this means is this line is going to be somewhere very close to 90 degree. Alpha is 90 degree means it will be in the east direction. Let me say that one more time. The wind direction is this way. The flag is fluttering this way. And then the resultant, we thought that it's somewhere here, but as I told you, it's not a scale diagram, which means according to this calculation, it's coming very close to 90 degrees, something like this, which means the flag is going to be in the direction of the east direction. That's the answer. Again, this is a slightly approximate calculation. So since this is coming very close to 72, this and this will become 0. So anything by 0 or a very small number will give me very close to 90 degrees. Any questions, any doubts? Take it down quickly.
Equal to, that is the equal to which is in curve, sir, it means it is close to 90 degrees, sir.
Yeah, it's approximately equal to.
Okay.
So 51 root 2 will come as 72 only, sir. 72.12.
Yes,
okay,
sir.
so maybe I did a.
It's 72.12.
Okay, very good. So root. Okay, how do I do this? Root 2 into 51. Yeah, 72.12. Yeah, you're right. So that means 72.12 minus 72, so 0.12. 0.12 is very close to 0. So 72 by 0.12, and if you do the tan calculations, it will come very close to 90. Okay. So what this means is the flag is going to flutter in the direction of east. So take it down properly. Any questions, any doubts? Remember, diagrams are very important. Okay, so if you do your proper diagrams, most of the problems will be over there itself. Okay, if you make a mistake here, everything will go wrong. Okay, these things right now, maybe you're studying this in the mathematics right now, so that's why I'm just giving it again and again. Maybe once you get comfortable, we may not we may not be spending too much time on these things. We have to keep going first. Okay, anybody still copying? Can I change the screen? Okay, so let's see. Ceiling of a long hall. Okay, maybe I'll give you the method. You can try it yourself. Okay, this one is also easy. 15th one. The ceiling of a long hall is 25-meter high. So it means what is the maximum horizontal distance that a ball thrown with a speed of 40 meters per second can go without hitting the ceiling of the hall? Maximum horizontal distance. For maximum horizontal distance, what is the angle I should throw it? Anybody?
45 degrees.
45 degrees. Yeah. 45 degrees. So you know that 45 degrees will give you the maximum horizontal distance, which is your range. So it means this is already they given a hidden note that it is 45 degree. Okay. So by saying maximum horizontal distance. So ceiling of long hall is 25-meter height. So that means you have to utilize this height as much as possible, right? So that means this height is given as 25 meters high. With a speed of 40 meters per second. So that means you are throwing the velocity of 40 meters per second. So initial velocity is 40 meters per second. Can go. So that means they're asking you to find this distance. So any idea what I can do? I know h max. So I know the height in the y direction. I know I can find the y direction initial velocity, right? So that means I can say that this is ux is equal to 40 cos 45. Similarly, uy is equal to, I don't have space here, maybe I can write it over here, okay. Uy is equal to 40 sine 45. So I know the height max, right? So I know the gravity in the y direction, which means I can find the time taken. Once I find the time taken, I can substitute it over here. Okay. I'll give you a couple of minutes. Can you try it yourself? Try it quickly. We have done this in the theory itself once. E squared is equal to u squared plus 2as. So if I put y, final velocity here in the y direction is 0. So this becomes 0. Uy is this one, 40 sine 45. So 40 sine 45. Don't forget there is a square. Plus 2ay. So ay is acceleration, so minus 10. Sy is 25. Okay, so what's the mistake I'm doing here? I want to find the time, right? So this is not going to help me. So we already discussed this in the theory. This formula will not help here. because you know everything here. So v is equal to u plus at, y 40 sine 45 minus 10 into t. So this 10 and 40 will cancel. So 4 sine 45. So t is equal to 4 sine 45. Sine 45 is 1 by root 2. So 4 by root 2. That's the time. So that is only to reach this distance. So that means the time of flight will be 2 times this. So that means it will be 8 by root 2. So to find this distance, I will say s is equal to ut plus half at square. And you know that this is for x direction. And acceleration in the x direction. Anybody? Anybody pulling it in the x direction?
No, sir. Zero.
So we say that this will become 0. Sx is what they are asking you to find this range, which is this distance. Ux is 40 cos 45. And the time taken is, the total time taken is time of flight, which is 8 by root 2. So this is also 1 by root 2. So 1 by root 2 and root 2 will become 2. So 2 and 8 will cancel to 4. 4 into 40 will become 160. So 160, is that correct or am I making a mistake? Cos 45 is 1 by root
It's
2.
20 meters.
3?
So it's 40 into root 2, no, sir.
40 into root 2.
Root 2 cancel 8 into 40.
But I thought this is cos 45 is 1 by root 2. So 1 by root 2 into
So sine 45 is, yes, it's 1 by root 2, so sorry.
Sir, it is 80 meters, sir.
80 meters. Why?
So it's 160.
I'm getting 8 here. So this will become
So it's
2.
80, it's 80.
So 2 and 8 will cancel to 4. 4 into 40 will give me 160. Any issues? Anybody?
Sir, I get 80 meters, sir. 40 into 8 by 2, no, sir.
40 into 8 by 2. Okay. So
So it's
2.
160.
Yes, sir. It is 160.
I believe.
So it's 160 only, sir.
Yeah. The book answer shows 150, but maybe they must have used 9.8 here. Okay. If you're using calculator, you can get the exact number. But for our calculations, I think this is fine. Okay, as long as you understand the concept. Again, for the accuracy of the numbers, I would say whatever your school teachers are telling you, do that. Okay. But in my opinion, taking this as 9.8 and breaking your head, I think it's not worth it. Okay. It's more, you should know more about the concepts. In real life, nobody is going to break your head with multiplication, division. So it's all computers and calculators. So you should know the concept how to do it. And don't forget, maybe I will not explain this properly. In the projectile motion problems, it's very, very important in many aspects. Even in your electrical chapters in your 12th standard, very often you're going to get projectile motion problems. You go for mechanical engineering, very often you're going to get this. Okay. Or if you go for National Defense Academy or military engineering, something like that. So all these things are how you launch a missile, where it goes and launch drops. Okay. Or if there is a flying. So, and if there is a bomb dropped or some object is dropped, what is the path it's going to take, where it's going to land, depending upon the speed over here, right? And what is the height? So there are a lot of applications for this projectile motion. Okay. Any questions? So I simply did the x direction, y direction, which we already discussed. That's all. Nothing very difficult here. Okay. If nobody is copying, I can change the screen.
Yes, sir.
Okay, let's see. 15 we finished. 16. What did I say? 16 is medium. Okay, let's discuss 16. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. How much high above the ground can the cricketer throw the same ball? So it means they're saying that a cricketer can throw with some velocity. Maximum horizontal distance means again it will be 45 degree, which means you can immediately assume that it is 45 degree. If he throws that, it's going to a maximum distance of 100 meters. How much high above the ground can the cricketer throw the same ball? So suppose if I throw the ball in the vertical direction with the same U, what will be the maximum height it reaches? That's the question. So what this means is, using this information given here, I should be able to calculate the U. And once I find the U, I can use it for the vertical direction. And with that, I can calculate the maximum height, because here the velocity will be 0. So I can calculate the maximum height reach here. That's the idea. So I think I'm going to leave it as a homework. So try it yourself. So which method you will use here? So U, again the same story. S is equal to ut plus, but I don't know the t. So t is using this one, you have to calculate. Again, if you remember the formulas, you can do that. Otherwise, if you don't remember, you have to, every time you have to go back to the basics here. So you know that V is equal to U plus AT. So this becomes 0. This becomes U sine theta. This becomes minus G. This becomes T. So that means T is equal to U sine theta by G. Okay. So if you don't know how to remember this, then at least remember this method. You can quickly derive this. And time of flight will be 2 times this. Because we are calculating the time taken for it to come here, so that means this will be 2 times this. So in the x direction, it will be time of flight, the total time for it to come from here to here. Ux is u cos theta. Okay, this is u cos theta here. This is u sin theta. Time of flight is 2u sin theta by g. So this is what we derived it as sin 2 theta. So u squared sin 2 theta by g. Again, if you remember this directly, you can do it. But very often students make mistakes, combining this and this. So here you will put sin theta instead of sin 2 theta, and everything will go wrong. So better go by the proper method so that you don't make any mistakes. So this is given as 100 meters. This is maximum, which means this will become sin 90 will become 1. 45 into 2 is sin 90. So sin 90 will become 1. So G is 10. So that means U squared is equal to 1000, because 10 into 100. So that means U is equal to root of 1000. So it means a cricketer can throw the same velocity in the vertical direction, which means I have to find the H max. So that's all. So this point Vy is equal to 0. V is equal to 0. So that means, which formula can I use? I think I can use V squared is equal to U squared plus 2as. Final velocity is 0. U squared is 1000 minus 20 into H max. So H is equal to 1000 by 20. So 1000 by 20 is 100 by 2, so it will be 50. So approximately he can throw up to a height of 50 meters. Anybody not following anything? So basically I'm finding the velocity with which he can throw, and then we are calculating the vertical direction. That's all. So this is separate problem, this is separate problem. Only thing you are taking the u from here to here, that's all. So read the question. I myself solved it, instead of giving it as a homework. Okay. And in fact, we derived the entire thing again. Okay, we already did this derivation. I just derived it quickly to show you that it's very easy. You don't have to mug up anything. If you know the basics, you can get it soon. Okay, anybody copying? Can I change the screen? Okay, so 4.17, let's see. 4.17 is easy, so I'm going to leave it to you. 4.18 is also easy. 4.19 is difficult. I given it as difficult, but it's like a theory question. Okay, let's talk about this. Read each statement below carefully and state with reasons if it is true or false. The net acceleration of a particle in circular motion is always along the radius of the circle towards the center. So what do you think? Net acceleration of a particle in circular motion is always along the radius of the circle towards the center. Is that true or false? Anybody? Is it always towards the center or does it change?
That changes.
When?
Every time, so when it moves, it goes in every direction. So if it's a circular motion.
You are talking about the tangential velocity, but read the question again. Are they talking about velocity or are they talking about acceleration?
Accelerations.
So acceleration, what did we say? Force. What causes the circular motion? Force towards the center. Force towards the center is your centripetal acceleration. So it means the radial acceleration or the centripetal acceleration is going to be always acting towards the center. But this is true only in uniform circular motion. Okay. It is uniform circular motion. What did we say about acceleration tangential? Anybody remember? Is there any tangential acceleration in uniform circular motion?
No, sir.
Why? Because the speed is not increasing, which means this will become zero. But did they say uniform circular motion or simply circular motion? Simply circular motion, which means, what do you think? Can there be a tangential acceleration? Yes or no? Yes, which means tangential acceleration is this way, radial acceleration is this way, which means the resultant acceleration will be this way. So this is your resultant. So take it down. This is why I told you sometimes they don't give you in the theory, but they will ask you in the questions. That means for uniform circular motion, yes, what they are given is true for a uniform circular motion, but not for all circular motion. So it means this is false. Velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. Velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. Yeah, that sounds correct, right? because velocity is always tangential to the point. It means B sounds correct to me. So this is true. The acceleration vector of a particle in uniform circular motion average over one cycle is a null vector. Anybody can explain what this means? Average over one cycle. What does that mean? You have to add all the values, right? That's what is your average. So
So null vector is basically when there is no direction and the magnitude is equal to 0.
yeah, so null vector means it will become 0. Magnitude will become 0. That's the meaning of null vector. Okay, very good. So what this means is, suppose if you add all the acceleration vector of a particle in uniform circular motion, so that means you see this is one acceleration, this is another acceleration, so both will cancel. Similarly, this will be this way and this will be this way. So if I add all the accelerations over a full circle, right, it will become 0. So that means this is also true. So that is not making sense. Let me draw it one more time. So this is one acceleration, this is another acceleration. So at every point the acceleration is something like this. So if I add all these vectors, right, what will happen? It will become 0. That's what you are trying to say. So that's what they mean by average over one cycle. Okay.
There is the acceleration at every point same, sir.
Acceleration at every point is same, but the direction is changing, right?
Yes, sir.
So that means this. So think about it. If I consider one acceleration this way, there will be a corresponding acceleration this way. Do you agree? Do you agree? Yes, no?
Yes, sir.
That means these two will cancel. So similarly, if I consider one acceleration this way, a cycle, there will be one this way, which means both will cancel. So that means averaged over one full cycle will be 0. That's what we're trying to say.
That-
Okay. 4.20, did I give it as easy or medium? Okay, I gave it as medium. Okay. So this also easy one, 20, but just involves a little bit of differentiation integration. So let's do that. For your school exams, my recommendation is make sure you are thorough with the textbook problems. Okay. So only if you're thorough with this, you will be able to, answer the difficult ones. Okay. The position of a particle is given by this ijk meters, where t is in seconds, and the coefficients have the proper units for r to be in meters. To find the v and a of the particle, velocity and acceleration. And remember, this is vector. Okay, bold letters means vectors. What is the magnitude and direction of the velocity of the particle at t is equal to 2 seconds? Okay, I think we did something very similar to this in the example, but we can still do it. So v is equal to dr by dt, which means I have to differentiate this. If I differentiate this, I'll be getting 3t will go away, minus 2 into t square. So 2 comes to the front, t power 2 minus 1, differentiation, j cap, for this is a constant. I feel like we did already this, right? Exactly the same numbers I remember. Did we do this? Can you check your notebook? Okay. Remember getting the same numbers.
Yes, sir. Same problem.
So did they give the same problem in the example and in exercise? It's very weird. Okay, then I'm not going to do this. Okay. You can double check it there. And remember, since you have IJK, right, this itself gives you the direction also. So actually I should write this like this. Yeah, by dt. So this itself is a vector. And if I want the velocity at 2 seconds, I have to substitute here. So I'll be getting, this will be minus 4 into 2 will give me 8. If I want the magnitude, I will be getting it as V magnitude. It's nothing but 3 squared plus 8 square. It's 9 plus 64, whatever that is. How much is that? 73, root of 73. Okay. Acceleration, if you differentiate this one more time, you see this will go away. I'll be getting minus 4j. So it means acceleration is equal to dv by dt. Anybody, if you don't understand the differentiation, you have to go back and check the handbook notes, the third chapter, or ask Satya madam, okay, to help you with this. Some of you were not there when I taught this. So dv by dt, so v is this one. So this will go away because it's a constant. This is minus 4t, which means I'll be getting minus 4j. So that means acceleration is in the negative direction. So magnitude and direction of the velocity of the particle at t is equal to the same. Okay, here I found the velocity magnitude, I didn't find the angle. So that means 3i is going to be somewhere here, minus 8j is going to be somewhere here. That means it's going to be somewhere here. So if I want this angle theta, tan theta is equal to y by x. So y is minus 8 divided by x is 3. That means this will give me theta which is in the negative direction. That's all. Okay, that's a very easy one, but every time I give this, because sometimes you folks are a little bit confused with this differentiation because you're not studying this in the mathematics right now. So that's the reason I'm just giving this. Otherwise, it's all simple mathematics. Okay, take it down quickly. Okay, so whichever I given it as difficult and medium, I'll be completing this. Okay, so here I have another 3 problems. Here I have another 2 or 3 problems. So I'll be completing those things. And then I think I left this vector problems. So we'll do that. All the other easy ones, I expect you to do it yourself. Okay, so easy ones, do it yourself. If you have doubts, we can discuss. So another class, I think I'll be completing this. So which means today is what? Friday. So Monday again we'll be having the class. So I can give one more extra class to make sure you're thorough with the concepts. So next Friday we'll have the test. Okay, so 30th we'll have the test. So make sure you're studying all these things. You have enough time. So study. Even if you do some, say, 5 problems every day, right? You can easily finish all these things very easily. Okay, so I'm going to stop here. Okay, as I told you, I have another say 4 or 5 problems to finish. All the remaining things you have to try it. Okay, easy ones you should try it. When I say easy, it's really easy, like just formula substitution. If you know the formula, if you have attended the theory, if you know the formula, you can do it. Okay, thank you all. If you have any doubts, stay back. Otherwise, you are free to go.
Thank you so much.
Thank you, sir.
Thank you, sir.